The light inside never goes out. The machines do not pause. Somewhere in this building, right now, the pipe is being drilled, love is steel, and an relentless in its pursuit of consistency. From above, the full scope of what happens inside becomes apparent. Trucks arriving, trucks departing. A facility in continuous motion. This motion. This pallet represents the end of one journey and the beginning of another. From growing region to receiving dock to roasting drum to sealed bag to carton to pallet, every step documented, verified, and traceable. A single sealed bag of coffee. Behind it, an entire system engineered to produce millions exactly like it. Every one roasted to the same profile, ground to the same specification, sealed to the same standard. Thermal imaging adds another layer of mechanical insight. A subtle temperature anomaly in a bearing housing, invisible to the naked eye, appears immediately on the thermal display, giving maintenance teams the lead time they need to act. Predictive maintenance programs use vibration analysis to detect early signs of wear in rotating equipment. By identifying issues before failure occurs, the facility eliminates downtime, one of the most costly disruptions in high-volume production. Hundreds of data points are monitored in real time across the production floor. Temperature, pressure, fill weight, seal integrity, moisture, every parameter tracked, every deviation flagged, every trend recorded for analysis. Viewed from above, the full scope of the operation becomes clear. Every system, roasting, grinding, packaging, palletizing, running simultaneously, in sequence, as a single integrated machine. Roasting exhaust passes through afterburner systems before being released to atmosphere. These units oxidize volatile organic compounds and particulate matter at high temperature, ensuring that what leaves the facility meets strict environmental standards. Coffee chaff, the papery skin that separates from beans during roasting, is collected continuously and directed toward composting or biomass use. Nothing in a modern facility is wasted if it can be recovered. Energy consumption is tracked across every major system in the facility. Roasters, grinders, HVAC. Real-time monitoring identifies inefficiencies early and supports the facility's ongoing commitment to reducing its energy footprint. Pest monitoring stations are positioned at regular intervals throughout the facility perimeter. They are inspected on a defined schedule, and any evidence of activity triggers immediate investigation and corrective action. Every person who enters the production environment follows strict personal hygiene protocols. Dedicated workwear, hairnets, gloves, and defined hand-washing procedures enforced at every entry point. Surface swabs are taken from all food contact equipment after cleaning. These samples are tested for microbial content, and the results must fall within defined acceptance criteria before the line is cleared for production. Between every production run, the facility's sanitation team moves in. Food-safe cleaning solutions are applied to all production surfaces. The process methodical, documented, and strictly timed before any production resumes. At the dispatch bay, a final verification confirms that the outgoing load matches the order documentation exactly. Correct product, correct quantity, correct lot, correct destination, before the truck doors close and the shipment departs. The warehouse management system maintains a live inventory of every pallet in the facility, its contents, its age, its destination. First in, first out rotation is enforced automatically, ensuring no product sits beyond its optimum dispatch window. When an order is ready for fulfillment, automated guided vehicles retrieve the correct pallets from their assigned rack locations and carry them silently toward the dispatch bay, guided by sensors, directed by the warehouse system. Every pallet is stored by lot number, its position tracked within the warehouse management system. The organization here is not cosmetic. It is the foundation of the facility's traceability and recall capability. Finished products move into the finished goods warehouse, a large, climate-controlled space where temperature and humidity are maintained to protect the packaged coffee throughout its storage period. A final check weigher confirms the net weight of each sampled bag against its declared fill weight. The tolerance is tight, and every result is logged as a permanent record of that production run. Beyond the automated systems, trained quality inspectors pull physical samples from every production run. Seals are examined by hand, weights are verified, and all findings are entered into facilities' quality management records. X-ray inspection systems go further still, detecting glass, stone, dense plastics, and other foreign objects that metal detectors cannot identify. Together, these systems form a comprehensive barrier against physical contamination. Every bag on the line passes through a metal detection arch. The system can identify ferrous, non-ferrous, and stainless steel contaminants smaller than a millimeter, and any bag that triggers it is removed from the line instantly. The completed pallet is wrapped in stretch film by an automated ropper orbiting the load in steady, overlapping passes. The film binds every carton into a single secure unit, protected against moisture, dust, and movement. At the palletizing station, a robotic arm builds each pallet with methodical precision, layer by layer, each course offset from the one below to interlock the load and maximize stability during transport. Hot melt adhesive is applied precisely to the carton flaps by an automated sealing head. The flaps fold and press shut in sequence. The carton sealed, coated, and ready for palletizing. Individual retail bags are now collected and packed into shipping cartons by robotic case packing arms. Each bag is placed according to a program pattern, maximizing carton density while protecting the integrity of every seal. A vision verification system reads every printed code as it passes. Illegible, missing, or incorrect codes result in automatic rejection. No unlabeled product leaves this line. Immediately after labeling, a high-speed inkjet coder applies the production date, lot number, and best before date directly onto the packaging. This code is the key to full traceability, linking every bag to every stage of its production history. Sealed bags move into the labeling station. Automated applicators press pre-printed labels onto each bag with precision. Product name, ingredients, net weight, and country of origin applied consistently to every unit. Periodically, finished bags are tested with a headspace analyzer. The residual oxygen reading must stay below 1%. Any result above that threshold triggers an immediate review of the nitrogen flushing system. The finished bag feels firm and full, a pillow of nitrogen holding its shape. This is not just functional. It tells anyone who handles the product that it has been packaged under a protective atmosphere. Just before the sealing jaws close, a food-grade nitrogen nozzle purges the headspace inside the bag. Oxygen is displaced entirely, and with it, the primary driver of coffee staling is eliminated at the source. Every sealed bag passes beneath a vision inspection camera. The system checks seal position, bag closure, and label alignment at production speed, confirming each unit in less than a second. The sealing station completes its cycle. Jaws press, hold for the precise dwell time, then release. The result is a clean, uniform seal line that will protect the product from the moment it leaves this machine to the moment it is opened. The scale releases its calculated dose into the bag below in a single, controlled pour. The fill weight is accurate to within fractions of a gram, thousands of times per hour, without variation. Above the filling station, a multi-head combinational weighing scale cycles at high speed, its buckets cascading coffee between chambers, computing the precise combination of weights needed to hit the target fill weight exactly. The sealing jaws close with calibrated temperature and pressure, fusing the inner laminate layers into a permanent, airtight bond. The seal is formed, verified, and the bag moves forward, all within a fraction of a second. In a single continuous motion, the machine unrolls the film, forms it into a tube, fills it with a precisely weighed dose of coffee, and seals it shut. Hundreds of bags per hour, every one identical. The packaging line begins with rolls of multi-layer laminate film, engineered with outer printed layers, internal foil barriers, and food-grade inner sealing surfaces, loaded onto the form-fill seal machine's unwind station. One-way degassing valves embedded in the packaging provide a second line of defense, allowing carbon dioxide to continue escaping from inside the sealed bag while keeping oxygen firmly out. After roasting, coffee releases carbon dioxide, a natural byproduct of the process. Before packaging, beans are held in ventilated degassing silos, allowing this gas to escape gradually over a controlled rest period. The control station displays a live particle size distribution graph, a bell curve that tells operators at a glance whether the grind is on specification. Adjustments to the burr gap are made here, precisely and without interrupting the line. Downstream, a particle size analysis sensor continuously monitors the grind as it flows past. If the distribution drifts outside the acceptable range, the system alerts the operator immediately. Ground coffee exits the machine in a continuous, rich-colored stream. The uniformity of the particle size is visible even here, a consistent texture that reflects the calibration of the burrs above. Inside the burr chamber, two hardened steel surfaces rotate in opposing directions. Beans enter the gap between them and fracture into uniform particles, the grind size determined entirely by the precision of that gap. Roasted beans feed from overhead hoppers into the grinder's inlet in a smooth, controlled stream. The machine draws them in steadily, no surging, no interruption. Roasted beans approved for grinding move into the grinding hall, where rows of industrial burr grinders operate continuously. Each machine is calibrated to produce a specific particle size for a specific product. Roast loss is calculated by comparing the weight of the beans before and after roasting. This figure is a direct indicator of roast consistency, tracked for every single batch, every single day. A calibrated colorimeter measures the surface color of the ground sample and assigns it a precise numerical value. That value is compared against the target for the product. Any drift outside tolerance triggers a review. Every roasting batch is evaluated in the cupping room. Small samples of freshly ground coffee are brewed according to standardized protocols. The same process, every time, for every batch. Inside the destoner, differences in density do the work. The bean flow continues uninterrupted while denser foreign objects are deflected onto a separate path, quietly removed without slowing production. From the cooling tray, roasted beans move directly into the destoner, a machine designed to catch anything that should not be there. Stones, dense fragments, and foreign objects are separated here before the beans proceed. The steam rises from the bean layer as temperature drops. This cooling stage is as critical as the roast itself. Even a few degrees of residual heat can continue developing the profile well beyond the intended target. Strong upward airflow floods the cooling tray, rapidly drawing heat away from the bean mass. The rotating arms of the tray move the beans in slow circles, ensuring every bean cools at the same rate. At the precise moment the target roast level is reached, the discharge valve opens. A cascade of dark, freshly roasted beans pours onto the cooling tray below, the roasting phase complete. As roasting continues towards second crack, the bean's cellular structure begins to break down further. Oils migrate to the surface. The color deepens to a rich chocolate brown, and the profile shifts into darker roast territory. Then comes first crack. Internal pressure builds until the bean's cell walls fracture, a moment that marks the entry into light roast territory. From this point, every second of additional roasting deepens the profile significantly. The Maillard reaction begins. Amino acids and sugars interact under heat, producing the brown pigments and flavor compounds that define roasted coffee. The beans deepen steadily from yellow to tan to light brown. As internal temperature rises, moisture begins to leave the beans in the form of light vapor. Their color transitions from pale green to a warm, grassy yellow, the first visible sign that transformation is underway. On the roaster's control screen, a live roast curve tracks bean temperature and drum air temperature simultaneously. Every degree of deviation from the program profile is visible in real time. Inside the drum, beans tumble continuously. The rotation is deliberate. Every bean must receive equal exposure to the heat. In the early minutes, they absorb energy rapidly, their pale green color just beginning to shift. When the roaster signals ready, a weight-controlled valve releases the measured batch of green beans into the rotating drum below. The roast has begun. Before any beans enter, the roaster is brought to its precise target temperature. Preheating the drum is not optional. It is a critical step that defines the consistency of everything that follows. The roasting hall is the heart of the facility. Large industrial drum roasters, capable of processing hundreds of kilograms per batch, stand at the center of the operation, their steel housings radiating the controlled heat within. Once blending is complete, the mixed beans flow into intermediate holding hoppers, staged and ready to feed into the roasting line in a controlled, uninterrupted sequence. The vessel rotates continuously, tumbling the beans together until the blend is thoroughly uniform. Nothing is left to guesswork. The mixing time, rotation speed, and batch size are all precisely defined. Every blend is produced from a recipe developed by the facility's sensory team. Exact percentages of each origin, refined through repeated tasting sessions to achieve a consistent and repeatable flavor profile. Most commercial coffee products are made from carefully calculated blends of multiple origins. Here, automated systems draw precise weights of each variety and feed them simultaneously into a central blending vessel. Some batches pass through a dedicated preconditioning area, where humidity levels are adjusted to bring beans to their ideal moisture content before roasting. This step ensures the roasting process proceeds with complete predictability. The warehouse management system tracks every lot in real time: quantity on hand, date of arrival, time in storage. First in, first out rotation is enforced automatically, ensuring older stock is always used before newer arrivals. Every sack is stacked on raised pallets, allowing air to circulate freely beneath the load. This simple measure plays a critical role in maintaining the condition of the beans below. Wall-mounted climate panels monitor temperature and humidity in real time. The target range is maintained continuously: 15 to 20 degrees Celsius, 50 to 60% relative humidity, without exception. The warehouse is a study in organization. Rows of palletized sacks extend across the lot, each lot clearly identified, the air held at a steady temperature and humidity to prevent any premature aging of the beans. Approved batches are moved directly into the raw materials warehouse, where conditions are carefully controlled to preserve the integrity of the beans throughout storage. Under precise examination lighting, inspectors assess each sample visually, checking for uniformity, physical damage, and any signs of contamination before a single bean enters the production stream. Calibrated moisture probes are pressed into bean samples drawn from multiple points in the shipment. Industry standards require a moisture level between 10 and 12%. Any deviation, and the batch is flagged immediately. Before a single sack is unloaded, documentation is reviewed. Every shipment arrives with detailed records: origin, variety, altitude, and processing method, all logged into the facility's tracking system. Inside each truck, tightly packed sacks of green coffee beans, dense, pale, and carrying the raw potential of every cup that will follow. Large freight vehicles arrive at the receiving dock carrying shipments from thousands of kilometers away, sourced from the world's most productive coffee-growing regions. It all begins with green coffee beans, unroasted, raw, and traveling through the facility's intake systems toward the first stage of production. Step inside, and the scale is immediately overwhelming. Row after row of stainless steel machines, automated conveyors, and sensor-driven systems work in perfect coordination. Somewhere in the world, right now, a factory never sleeps. Behind these walls, millions of coffee bags are produced every single day, with a level of precision most people never see.